Quantum mechanical model of atom. In 1913, Niels Bohr used what had recently been discovered about energy to propose his planetary model of the atom. In the Bohr model, the neutrons and protons are contained in a small, dense nucleus which the electrons orbit in defined spherical orbits. He referred to these orbits as shells or energy levels and designated each by an integer 1, 2, 3, etc. An electron occupying the first energy level was thought to be closer to the nucleus and have lower energy than one that was in a numerically higher energy level. Bohr theorized that energy in the form of photons must be absorbed in order for an electron to move from a lower energy level to a higher one, and is emitted when an electron travels from a higher energy level to a lower one. In the Bohr model, the lowest energy state available for an electron is the ground state, and all higher energy states are excited states. In the 1920s, Werner Heisenberg put forth his uncertainty principle, which states that at any one time it is impossible to calculate both the momentum and the location of an electron in an atom. It is only possible to calculate the probability of finding an electron within a given space. To describe the location of electrons, we use quantum numbers. Quantum numbers are basically used to describe certain aspects of the locations of electrons. For example, the quantum numbers n, l, and ml describe the position of the electron with respect to the nucleus, the shape of the orbital, and its special orientation, while the quantum numbers ms describes the direction of the electron's spin within a given orbital. Below are the 4 quantum numbers showing how they are depicted and what aspects of electrons they describe. Principal quantum number n has positive values of 1, 2, 3, etc. As n increases, the orbital becomes larger. This means that the electron has a higher energy level and is less tightly bound to the nucleus. Azimuthal quantum number L has values from 0 to n-1. This defines the shape of the orbital, and the value of L is designated by the letters S, P, D, and F, which correspond to values for L of 0, 1, 2, and 3. In other words, if the value of L is 0, it is expressed as S. If L is equal to 1 is equal to P, L is equal to 2 is equal to D, and L is equal to 3 is equal to F. Magnetic quantum number ML determines the orientation of the orbital in space relative to the other orbitals in the atom. This quantum number has values from -L through 0 to +L. Spin quantum number ms specifies the value for the spin and is either +1/2 or -1/2. No more than 2 electrons can occupy any one orbital. In order for 2 electrons to occupy the same orbital, they must have opposite spins. Finally, you should keep in mind that according to the Pauli exclusion principle, no 2 electrons in an atom can have the same set of 4 quantum numbers. This means no atomic orbital can contain more than 2 electrons, and if the orbital does contain 2 electrons, they must be of opposite spin.